When a reader is required to draw conclusions from the information presented in graphs, tables, charts, or diagrams, it is important to limit these conclusions to the terms of the graphic itself. In other words, the reader should avoid extrapolating from the data to make claims that are not supportable. So consider this graph as an example. It compares the price of bread to the demand for bread. So notice here, as demand rises, price also rises, because over here, see, price is very high, well, demand is also very high. Well, notice here, when demand is low, price is also very low. So we know here that price and demand relate to each other in some way. We can't look at this graph and say, oh, it's just coincidence that price and demand rise and fall together. No, we know there's some relation between price and demand here. But that's all we can tell from this diagram. See, we can't look at this graph and say, oh, when price rises, it causes demand to rise. We can't say that because it may be demand rising that causes price to rise. Or it could be some other variables and factors that are not included in this graph that play an important role in determining demand and price. So the important thing is when someone analyzes a graph that they don't read too far into that graphic organizer or the diagram, graph, pie chart, whatever that graphic organizer may be. It's important that the reader just take that graph at face value and only draws conclusions that are supported by the graph.